Okay, so if we just did direct substitution and you plugged in the 2 for the x's, you get 0 over 0. So if on your paper you wrote that the limit equals 0 over 0, just mark out the equal sign. And we're going to do this little arrow. That means it yields 0 over 0. This limit does not equal 0 over 0. So if this was a free response question and you wrote that, they're gonna deduct you for that. Because in a second we're gonna find out what the limit actually does equal. So it is okay if you do a little arrow. Some people, instead of doing that, they would do something like 0, 0. That's fine. All of those things are fine, but just don't say that this limit equals 0 over 0. Some people go over to the side, plug it into the numerator and say that's 0, plug in denominators, that's fine too. All right.
Can I put equals undefined?
No. Limits are not undefined. Limits don't exist or they have a value. Yes.
So, just to be clear, if this was a free response question, would you have to write the 0 to 0?
At some point you would, well, it just depends. That would be part of showing your work, maybe. There is something we're going to learn later, and then you kind of do need to show that you get 0 over 0 to be able to use this other thing. So anyway, we'll say maybe you would have to. All right. So then they told you to look at the table, look at the graph, and on the graph there is a hole that does not show up. So just remember that's a glitch in the calculator. You can't always count on that. All right, and then they also ask you to look at the table. Now on the table, I don't want it to be on ask. I want it to be on auto. Okay, and so there is an error there. So in that blank on A, you can just fill in error. And then we want to figure out what this is actually approaching. So you can look at patterns here. So if you're looking at how the numerator and the denominator are changing, what should be in the place of 2? If you're just looking at what's changing, like the pattern. You ready? 5/4. So it looks like the numerator is increasing and the denominator is increasing. So in that place where the error is, I would say that should be a 5/4. Some people in this place do a decimal, and that is okay. Also, I think the fraction's a little easier to see. The decimal, if you guessed, would have been 1.25. All right, and then number 3 says let's try simplifying by factoring. So you would factor the numerator and the denominator. And then see, can this be further simplified? It can, because those 2 can get canceled out. And now we would plug in 2 into the new fraction. And we get what we said it was supposed to be, 5/4. That is the value of the limit. So the limit as x approaches 2 of that whole original fraction is 5/4. And we all know limits do exist at holes as long as it's with the flow of the graph. It's not, doesn't have like an end point, that's a hole. All right, and then 4, find the limit as x approaches -2 using the graph. What is that? What is there at -2? Do you remember what it's called? Vertical asymptote. Do limits exist at vertical asymptotes? No, the limit does not exist. So if we plugged in -2, if we plugged, -2. You would get -4 over 0. And that's way different than getting 0 over 0. So when you get 0 over 0, it means there probably is a value to that limit. The limit probably exists, and there's just other stuff you can do to find it. But if you get negative 4 over 0 or any other number over 0, the limit is not going to exist. It's going to be some kind of infinite approaching. All right, so let's just go on to the notes. And like I said, we're going to do half of this box and then about half of the examples today, and then tomorrow we'll work on the other stuff. All right, so we're going to do algebraic approaches. So before today, all we did, we looked at graphs and tables and tried to figure out limits that way. So today we're going to do some algebra stuff. And so sometimes people love this more than the other stuff. So if you love algebra, then maybe this is going to be a good day for you. If you don't love either of them, it's still going to be fine. All right, so the first thing we always want to do when we evaluate limits is do direct substitution. Sometimes when you do direct substitution, you get a number like 7, and that is the answer, and it's super easy. All right. And then sometimes we would need to use memorized forms. So I'm going to show you some memorized forms. That's why I left this space. I think I left a little bit more than what we need for the memorized forms. So one of them we have talked about already this year, and it is the limit as x approaches 0 of sine of x over x. So I can't remember what day we did that, but we looked at the graph and we looked at a table and we got closer and closer to 0. Does anybody remember what we got? What did we get?
Wait, closer to 0?
The x got closer to 0. What did the y values get closer to? Anything? It was 1. Yep, nice job. And so I'll just do a little reminder.
Does it equal 1?
The limit equals 1. The value doesn't equal 1. The limit equals 1. Because what happened is it came up like that, and then there was a hole there. That's what that graph looks like. Yes, ma'am.
What's the difference between yields and
Say it again.
What's the difference between yields and
Yields and equals. Well, if you say that this limit equals 0 over 0, that is wrong, because this limit equals 5/4. But if you say it yields it, you're saying when I plugged in 2 originally, I got 0 over 0. I know that's not the answer, because that's what's called indeterminate form, and we're going to fill that in just a second. But I know it doesn't equal that. It's just what I get. Does that make sense?
So
That's kind of weird.
if you get, but if you do direct substitution and you get a whole number, it.
Like 5? Yes, it equals that.
But if it's 0, 0, which is irrational.
If you get 0, yeah.
It's an answer that is not technically the wrong answer, but it's not the right answer.
It is what you get when you plug it in. It is just not what the limit equals. Here, I should have filled in some of this other stuff first. So let's do this over here on the right, or this little dotted box. So if you are doing direct substitution and you get a number over 0, then that limit does not exist, but the value associated with that is infinity, as long as that number is positive. So if you get 3 over 0, that correlates to infinity, right? If you are doing the same thing and you get a negative number over 0, what do you think that would correlate to? Negative infinity. All right, so if you're doing a limit and you get 0 over 0, or any form of infinity over infinity, that is called indeterminate form. So it's indeterminate. That is not the value of the limit. It means you have to do something to find the value. Right, what do you think it equals if you get a number like 7 divided by infinity? Yes.
Whenever you mentioned plugging the numbers in and it being like positive or negative, do you just pick any number or?
Now are you talking about this right here?
Yes.
This is saying that you do the direct substitution and you get it. You don't pick it, it's just something you get.
Oh, okay.
Okay. So what do you think it equals if you do 2 divided by infinity? What would that be? So a regular size number divided by the biggest number you could ever imagine. It's a value. It's an actual number. It is 0. Thank you. So a regular size, even if it was 100 divided by infinity, that is going to be 0. Okay. So this limit, when we plugged in 0, you do get 0 over 0. And at this point, what we need to do, just on what we know so far, is remember this as a memorized form. Okay. There's another form of this one, that is the limit as x approaches 0. It's very, very similar, but the x is going to have a coefficient. We're calling all of our coefficients k here, just to represent a number. Right? That is also going to be 1. So as long as we have the same coefficient on numerator and denominator, it's still going to be 1. Alright, and then there's one other that we haven't talked about, but it's one we need to memorize. It's harder to memorize, I'll be honest with you. Alright, it is limit as x approaches 0 of 1 minus cosine of x over x. And that limit is going to be equal to 0. Okay, so you might see those come up in our examples today and in your assignment. So just try, you can look back at them obviously, or try to remember them. Oh, it might be tomorrow actually. Alright, another thing we can do is algebraic, is factor, simplify, and then use direct substitution. We're also going to do algebraic manipulation. And this type mostly is talking about simplifying complex fractions. And then the last type is we can use graphs or tables. Now the main one that I kind of want you to memorize, so this could be in memorized forms and in memorized graphs, is the graph of something like y equals the absolute value of x over x. Do you guys remember what that looks like? Because it comes up a lot. We did it might have been yesterday. Do I remember what that graph looked like? The negative 1 and the 1? Alright, so it's going to look like this. And it's going to look like that at negative 1 and 1. Sometimes it's switched. And it is a situation where you do get 0 over 0, but the limit doesn't exist at 0. The one-sided limits exist. So don't think that always 0 over 0 there's an answer, but most of the time there is. Alright, let's do some examples. They're on the back. Some of these are super fast, so don't stress. We're only going to go to F today. Right, so the first thing we always want to do is direct substitution. You can do it in your head and just make sure it works, or you could write it out. But when I plug in 3, I get the square root of 4 or 2. That is the value of the limit. Those will be your favorite kind. Alright, I meant to pull out an old unit circle and I forgot. We're going to do the same thing. We're just going to plug 1 in for x. So pi times 1 is just going to be pi. All right, so I do need you guys to remember the unit circle.
Yeah. Turn me on.
You got it? All right.
Yes.
So who knows what the cosine of pi over 3 is? You already know? Wow.
Yes.
What is it?
1/2.
It is. Nice job, Keena. All right. Those of you that don't know, I can print you off some, or maybe you can remember how it all goes. But yeah, they'll come up from time to time, not super consistently, but you will need to pull some trigonometry from your brain.
Sadly, I can't erase it.
I love it. That's good. There's no reason to erase it.
It's in there.
Good.
It's not going anywhere.
All right, so let's look at C. When you see these little fractions, you probably need to start thinking that we're going to have to do something. It's not going to work out so perfectly. It could, but it's probably not. So when I plug in -2 to the numerator, I get 4 plus, what do I get? No, I get, 4 plus 8 minus 1. Oh, that's supposed to be a 12. Is yours a 12?
Yes.
Yes.
No, mine's
It's supposed to be 12.
Oh, wait.
I was like, this is not working. All right, if yours isn't 12, let's make it 12. I don't know what happened on my copy. All right, so I do get 0. I knew I was supposed to. I was super confused. And then in the denominator, -2 plus 2 is also 0. So what does that mean? Does not mean does not exist. It's okay. Yeah, it is the indeterminate form. It means you need to do something. And in this case, that something that you're going to do is factor. So I want you to just keep writing the limit until you've plugged in that -2 and gotten a real number answer. So we're going to factor the numerator and the denominator. Oh wait, just kidding. The denominator doesn't factor. If you got 0 over 0 in a situation like this, there will be something that cancels out. And then you can plug in the -2. And when you plug in the -2, you no longer write the limit. So that means that on this graph, when x is -2, you're going to have a hole when y is -8. All right, any question? Y'all okay? Okay, let's look at D. So I'm going to plug in that -2, and it looks like I'm going to get 0 over 0. So again, that just means it's indeterminate and I need to do something. All right, I don't remember how much time we really spent on factoring the sum of cubes last year, but I think we did. Who remembers how to factor this? What you got?
Isn't it a squared times 2ab? Is that what we're talking about right now?
What you're doing is when you square a binomial, which is something that's good to know. It's okay. When you find each cube root and you put them in the first set, it's not a, it's x. Don't be sorry. Shoot. Alright, then you're going to square the first one, change the sign, multiply them together, last sign is always a plus, and then square the second one. Okay, so I know that these x plus 2's cancel out, and I kind of expect that that's going to happen because I got 0 over 0. And then I'm ready to plug in the -2. And it looks like I get 4 plus 4 plus 4, or 12. right. And then this guy. So this is a complex fraction. Let's see what we get when we plug in 0. I'm sorry, when we plug in 3. So I get 1/4 minus 1/4 over 3 minus 3. So again, I'm going to get 0 over 0. This is not going to factor. So this is what is considered a complex fraction. When you have a fraction inside of a fraction, that's a complex fraction. And so this is this algebraic manipulation I was talking about. So I want to get rid of these little fractions. How can I do that? It's okay if you don't remember. Inverse?
Like multiply out?
Multiply by the little fractions. So we are going to multiply by denominators to simplify complex fraction. Now, to keep it legal, mathematically, I'm going to move this 0, 0 over a little bit more. We have to, what we multiply in the numerator, we're going to multiply in the denominator. So, our two fractions are x plus 1 and 4. We're going to multiply that by the numerator and the denominator. And we're going to keep writing limit until we can plug in 3 and not get 0 in the denominator. Alright, so if I multiply this first one, the one that's in front of the minus, by all of this, the x plus 1's cancel. And then I have to multiply 4 by 1. Does that make sense? So that's the whole point of it, is to get rid of these little fractions. So when I multiply these together, x plus 1's cancel, 4 times 1. Alright, then if I do this times this, what's going to cancel? The 4's. And then I need to multiply negative 1 by x plus 1. Now in the denominator, we are not multiplying any of it out in the denominator. So we're just going to leave it as x minus 3 times x plus 1 times 4. Alright, and then we're just going to keep on simplifying. Let's see what happens. More than likely, that x minus 3 is going to cancel out at some point, but it's going to take a minute. Do you all see a way where the x minus 3 can cancel? It's not super obvious like it has been on these previous ones where it looks exactly the same, because they don't look exactly the same. Can we make them look exactly the same? Okay, they're just opposites. So I can just factor a negative 1 out of the numerator. And then once that x minus 3 cancels out of the denominator, I'm ready to plug in my 3. Alright, so that was quite a bit of work. And it's probably what you're least comfortable. You've had the least amount of practice is simplifying complex fractions. I don't know if you had any practice doing that. Okay, we are going to do one more. I really wanted to have more time, but that's okay. All right, so we need to know what this graph looks like, because we do get 0 over 0 here. So 2 is the important x value. So you're going to have a horizontal line at -1 till I get to 2. And then you're going to have a horizontal line at 1. Now you did have to be a little bit more careful than what I'm being. Because sometimes it's the other way, like it's 1 and then -1. So if you're unsure, just plug in something on the left side of 2. So like plug in 0. If I plug in 0, I get 2 over -2. So that whole section is going to be -1 and the other one will be positive. Okay, so we are approaching from the right. So what should the value of this limit be? If I'm approaching 2 from the right. I'm just up here. Getting closer and closer. All right, what questions do you guys have? Okay, this is actually an assignment out of the book. I can go grab some if you want me to, but I also can post a picture of it on Google Classroom for you all. Or you can take your own picture.